So welcome everyone. Thanks for coming to the pitching session for my final year project on competition platform for AI tasks. So first of all, what is AI virtual learning environment? It's basically an online judge similar to LeetCode or Codeforces, but the key difference is that this online judge is specifically for reinforcement learning tasks. In other words, your program, instead of crunching numbers, should play a game and try to score as high as possible. What aiVLE aims to be is a complete solution for RL algorithm evaluation that is extensible, scalable, and easy to use. Completeness means this project covers everything from task creation to hosting competitions. We provide frameworks and instructions to help you convert any existing OpenAI gym environment to a competition on our platform. Extensible means this project is open sourced with a ton of documentation. You can check the Git history of this project and see the evolution. Scalable means the evaluation is distributed to worker nodes in a cluster. Lastly, easy to use, of course. The primary user happens to grade my project, so I better keep it user-friendly. So what's so special about RL tasks that we even need to start a new project for them? The first key difference is that RL tasks require interactive judging. On the left is how RL agent works. It receives reward and observation from the environment. Then take an action, and this loop repeats indefinitely until a terminating condition is met. On the right is a traditional OpenAI gym agent. Did you spot a fatal problem here? The problem is that the current structure is impossible to fairly evaluate. You never know if the student replaces the environment, or in extreme case, they just simply print a perfect score in the end. So our solution is to separate, isolate, and taking full control of the environment. Instead of running everything in one program, we separate the agent from the environment. As shown on the left, every rectangle is an individual process and program. Students only need to submit the agent part, and we have full control of the environment process so that cheating is almost impossible. What's even better is that this framework is fully compatible with OpenAI Gym. I did some magic behind the scenes so that both the agent and the environment thought they were running in a traditional OpenAI Gym framework. To use this framework as the agent, you only need to change one line. There's literally only one line of difference between the two. So the second key difference is that RL agent often requires intense computation. We need good scalability and non-compromising security. The scalability is enabled by a message queue. It achieves good resource utilization, up to 85% sustained peak utilization, and round-robin load balancing. The security is enabled by a sandboxing mechanism. We can limit the resource like RAM and VRAM and protect malicious behavior by file system and network restriction. This is the overall architecture of the system. On the client side, we have aiVLE Gym responsible for simulation. aiVLE Grader calls the agent implementation to interact with the environment and record the simulations. On the server side, we have a worker cluster consisting of many worker nodes, communicating with the aiVLE web server in an orchestrated manner. This cluster is designed to be fault-tolerant and massively scalable. And of course, aiVLE Web also provides a front-end that you can access from a browser. Then let's briefly talk about the performance. For load balancing, since it's round-robin, the distribution is very fair as shown here. For utilization, this is a graph of GPU utilization rate in the experiment. In this specific example, the worker node remains busy 96% of the time, and we achieved up to 3 times higher sustained peak utilization, which is a pretty decent performance gain. For scaling efficiency, we have achieved 92% and 85% efficiency for 2-node and 3-node configuration respectively. This is actually pretty good considering the fact that every job only takes 15 seconds to finish to begin with, and we still need to download a pretty large model file for every job. And put it another way, you can finish grading 100 submissions in 90 seconds with only 3 nodes. As for the worker performance, we can achieve 80% plus concurrency efficiency even if we stretch the system to the absolute limit. So, aiVLE is a complete solution for RL algorithm evaluation that is extensible, scalable, and easy to use. It is stress tested within SOC compute cluster and is proven to be very performant. and it's going to be in production next semester. So that's it. Thanks.